Hello, my name is Ruben Mukherjee, and as you can see on the screen, this is my design on AutoCAD 2022 for my artifact, part of the extended project qualification. Um, so yeah, this is the hydrogen turbo ramjet engine which I have designed, but specifically for the purposes of flights from Mach 0 to Mach 6. So let's dive straight in. So this is let me highlight it. This is the inlet spike component. So the main purpose of this component right here is that it creates an oblique shockwave. And what a oblique shockwave is when there's an object uh, relevant to the flow, when the flow is above Mach 1, which is at supersonic speeds, this is when it creates an oblique shockwave, so the air passes through the point here, and changes the properties of the gas, especially the temperature and the pressure of the gas across the spike. This is to ensure that uh, the combustion of this air can be much easier to combust with hydrogen because the temperature and pressure have increased. So specifically for this inlet spike, it has a deflection angle of 6 degrees, which I measured geometrically on this measurement tool for AutoCAD. Uh, yeah, and then the rest of the details are presented in the document. Now, just this, let's reset. Yes. So now this is the compression stage, where this is designed for the engine as a multi-stage axial compressor. This compresses, so this I couldn't run simulations online because it wouldn't accept DWG files. So I could explain what was going on instead. So the compression fans rotate, which suck in the air, which have been created from the shockwave from the inlet spike, and this therefore increases the pressure and temperature of the air across the compression stage. So as you can see, the levels of the stages of compression increase as from the first stage to the eighth stage, particularly in this compression region of the engine. Um, the values and parameters are again included in a document. So, and then next, this is a new component which I had designed to modify the engine, unlike shown in the document. This is a supersonic diffuser. So what this does, well, subsonic diffuser, because this directs the airflow directly in through the combustion chamber, through the hole in the opening valves. This creates another shockwave, so it furthermore increases the pressure and temperature across the air to combust with hydrogen. And now, as you can see, if I highlight this and isolate it and move, hopefully, this doesn't seem to work. Yeah, so this combustion chamber has uh, 8 opening valves, each containing a ring of hydrogen being transferred at a specific mass flow rate. Again, parameters involved in the document. This ensures that the hydrogen is being sprayed directly into the airflow through the valve opening, through the combustion chamber. The reason why it's spiky, so I'll just try to move this. Yes. So these are the spray injectors. These are cone shaped because these specifically increase the pressure of the hydrogen for combustion. Because since hydrogen is such an inflammable fuel, it needs to be controlled under specific pressures and temperatures to combust with the oncoming flow. So what this does is, so if I separate the ring around here, this ring contains hydrogen flowing throughout, and this combustion chamber is connected through a pipe to a metal hydride. So metal hydride is a type of hydrogen storage that can be used for fuel propulsion systems. So basically, a metal hydride is like a storage unit. So what it does is when hydrogen is being introduced to the metal hydride absorbs the hydrogen in, and it needs to be externally heated so the hydrogen is directly released into the ring, the tube, which is connected by a pipe wire through the storage unit. The hydrogen storage system is mainly complex and needs to be designed accordingly. However, that is not the main objective of my project. My main project is to use the harness the power of the hydrogen which is being stored. So next, if I move on to the turbine stage, if I highlight it again, this basically, as you can see, the turbine is being attached to a shaft which is connected to the compression fans right here. So when the high flow of air is passing through from the combustion chamber, which is the mixture of hydrogen and air, it causes the turbines to rotate. I'll just highlight it again. So when it rotates, it extracts the energy from the high flow air and it converts it to mechanical energy to rotate the shaft. So if I just isolate the shaft, which is in turn will connected to the compression stage. So in this, when the shaft rotates, it turns the compressors as well, the multi-stage compressors. This in turn creates a self-sustaining engine, which means that as you start the compression fans and turbines, you don't need more power output to turn the shafts mechanically. The turbines rotate it if there's a high-speed flow flowing through it. Next is the afterburner, which I try to move here. So if I split it around here. Yes. So as you can see, this is completely different from, well, has a completely different design from the combustion chamber, because if you look specifically, there are hydrogen spray nozzles around a tubular ring. This ensures that the efficient combustion, because the flow speed air through the afterburners are fast enough to be combusted because of its extreme pressures and temperatures. So it doesn't actually need the valves which are being used in here, which need to actually store more hydrogen and inject it at a higher mass flow rate. So therefore in the document it shows that the mass flow rate of the afterburner is much lesser than the valves in the combustion chamber, and in turn that produces thrust from the afterburner. Now this part, the last stage of the engine, is the turbo ramjet engine nozzle. So what I named this was the double control nozzle, which consisted of a convergent divergent nozzle, also known as a de Laval nozzle, and a variable nozzle as well. Now if you look at typical turbojet engines, the nozzle is just this, basically a variable nozzle, because as the gases from the afterburner expand through the variable nozzle, the gases kind of expand the nozzle through. So that's allowed to control the flow of the Mach of the air. But then the main reason why I included this convergent divergent nozzle is because it increases the Mach of the flow. Because of its design, the convergence, this diffuses the air through. So if I just highlight it again. Oh, just isolate it. Yeah. So as the air passes through here, the Mach is generally lesser than 1, so it's subsonic. But then as it goes through the diffuser in this part over here, this is when it's at sonic conditions. This increases the Mach to at least above, at least at a factor of 1.4 because of its gamma rate. So that was a compression, that was a convergence stage. Now this is the divergent stage. So if you look at typical diagrams, for example, like a rocket engine, you see that this type of nozzle is being used. This is because a high exhaust Mach flow is required to produce essentially more than 200 kilonewtons of thrust. Yes, so that was the details of the turbo ramjet engine. The parameters are again shown in table.